Hi, do you know what's odd about the electronic configuration of the following elements? No? No worries, join my class. Hi everyone. Today we are going to talk about the exceptions in writing the electronic configuration for some elements. Don't forget to answer the questions at the end of the video and put your answers in the comment section below. Thank you. Let's start by writing the electronic configuration for chromium with 24 electrons. By the way, I will add a link in the description below for a video explaining how to write the electronic configuration for different elements. And you follow the same procedure. The electronic configuration of chromium will end with 4s2 3d4, but this is not the case since chromium is an exception. In fact, the electronic configuration for chromium should end with 4s1 3d5. And let me explain why we jumped filling the d orbital while still the s is not complete. In fact, the different subshells that we learned before, the SPDF, are divided into suborbitals. As you can see, S it's made up from one suborbital, P 3, D is made up of 5, and F is made of 7 suborbitals. These suborbitals, when they are filled with electrons, we fill them with 2 electrons maximum, and as you can see, the 2 electrons should be pointing opposite to each other. One is pointing upward, one is pointing downward. So S can hold 2, P 6, and so on. So if we want to have a look on the distribution of electrons of chromium, in the first case, we can see that we have the S subshell is filled with 2 electrons, while the D subshell has 4 electrons in 5 different orbitals. In the second case, we can see that we have 1 electron in the S suborbital, while in the D we have in each one of the subshells we have 1 electron. So the D now is half filled. And the scientists, when they calculated the energies of the electrons, they found that the second case is more stable, and so it is the most common electronic configuration for chromium. Now let's have another example about the electronic configuration for copper with 29 electrons. If we write the electronic configuration the way that we used to do, it will end up with 4s2 3d9. But as I told you, copper also is an exception. It shouldn't be written like this. It should be written ends with 4s1 3d10. If you want to have a look on the distribution of electrons in the different subshells and see what's the difference between the first case and the second case. In the first case, we have 2 electrons in the S subshell and we have 9 electrons in the D subshell. So the S is going to be completed with 2 electrons, while the D we have 4 suborbitals completed with 1 unique electron in the fifth. In the second case, we have 1 electron in the S suborbital and all the D suborbitals are completed, which is the more stable case. And this is the case with many other elements like molybdenum, silver, gold, and others. So exceptions in writing electronic configuration happen in 2 cases, when it ends with S2D4 or S2D9. S2D4 you have to convert it to S1D5, which is more stable since the D subshell is half filled. S2D9 you have to convert it to S1D10, which is more stable since the D subshell is completely filled. Now it's your turn to answer. Pause the video, copy the questions, answer them, put your answer in the comment section below. Thank you.